excuse me. Okay, so we're about to get started, guys. Give me just 1 minute. Section 1.5. Okay. We're about to get started, guys. Give me just 1 minute. Section 1.5. Yay! I think we're good to go. Okay, so let's get going, guys. Now, am I still on mute? I'm not mute. So the group on Zoom, you guys can hear me fine, right?
Yes.
Okay, great. Now realize I can't, when I'm lecturing, I won't be able to see the chat anymore. So if you write something in chat, I won't see it till the end of the class. So you'll have to, you really will have to kind of butt in if you've got a question. And don't feel like you're butting in. It's just, that's how, if we're gonna do this way, this is how it's gotta work. Okay. So first off, before we get started, like my lectern thing there. Today we're going to go over 1.5, and then we're going to go, hopefully go over 1.7. Now 1.5 is a review of solving quadratics, okay? So the goal today is really just to review solving quadratics. There's 3 ways we're going to go over solving quadratics. And again, hopefully this is a bit of a review. I treat it like you've seen it already, but also if you need a more in-depth review, that's fine. Let me know and I can find some other videos I've made so you can watch them, or just other material. So not a big deal, but we're going to utilize solving quadratics a lot in this class. It turns out to be like in a few chapters, it'll be it'll really be the easy part, which is nice. So let's get going. Actually, the book in 1.5 starts with, sure, let's stay on track. It starts with solving equations by factoring. So I'm going to say solving quadratics by factoring.
What page will this be on?
It starts on page like 145-ish. Solving quadratics by factoring. So the goal when you solve quadratics by factoring is that you want to get one side equal to 0, and then you want to factor the other side completely. And then you just set each one of those factors equal to 0. So I'm going to do a very, very basic one first, and then we'll just build on it. Okay. And I teach this with examples because it is like a review. Okay. So let's look at a basic example. Let's say we've got, let's say 3x squared equals 15x. Okay. And we're going to solve this one by factor. Okay. We're going to solve it by factor. Now,
I still don't think you're recording.
You don't think I'm recording?
It says you're live, but it doesn't say like.
Yeah. So it's actually live on YouTube. So it's recording on YouTube. That's what I did last time too.
Okay.
Okay. So to solve by factoring, you're going to set one side equal to 0. Okay. Now it doesn't matter which side you get equal to 0. I'm going to move this 15x over. Subtract 15x on both sides. So you get 3x squared minus 15x equals 0. Okay, and then that's the first step. If you're going to solve by factoring, you have to have one side equal to 0. And when we get to like using the quadratic equation, same thing. There's some similarities to that. But for this example, we need, for factoring, we need one side equal to 0. And now we're going to factor the non-zero side. Now, there's a lot of ways to factor, right? But the very first step in any factoring is to see if it has a GCF, right? See if we can factor something out. In both of these terms, we have a GCF, right? 3 and 15 are both divisible by 3. I can factor that out, right? We've got an x squared and an x. So we can factor an x out. And there's nothing left over. So we're going to factor this GCF out completely, okay? Now, when we factor the 3x out of this first term, look, we factored the 3 out. We factored one of the x's out. So we're left with x. Okay? And we look at that second term. Look, if we factor a 3 out of here, we're left with a -5. We factored the x out, so we don't have an x left over. So there's our two factors, 3x and x -5. Now, so remember, like if you're writing down steps, first step, get one side equal to 0. Second step, which is the doozy, okay? You've got to factor the non-zero side, okay? And for this one, this was an easy one. We just factored out the GCF to factor the non-zero side. The third step is going to be to set each factor equal to 0, okay? We're going to set each one of these. Look, we've got two factors here, and it is not a coincidence at all that we have two factors containing an x and the degree of this polynomial is 2. Not a coincidence. We're going to have two solutions, okay? So we're going to set each one of these equal to 0. It's called the zero factor property if you want to Google it. And then you just solve, right? So divide by 3. 0 divided by anything is just 0, right? And then I'm going to add the 5. So we get x equals 5. Okay. Questions on the interwebs?
Are you going to want us to do it like points? So like it would be like parentheses 0, comma, and 5, or just leave it how that is?
No, these are two separate answers, so they're not coordinates. Is that what you're saying?
Yeah.
Yeah. No, these are just two distinct answers. Now in the back of the book, it might say 0, comma 5 but that's just separating the two answers. If this contained a y value and we were finding like x-intercepts, we'll get to that here in a few sections. That's when you would do that. So I'm glad you mentioned that. I'm glad you're thinking that way. But no, for this section though, we're just solving quadratics. So it'll just be solutions. Okay, but I want you to know what's nice about equations and what's nice about mathematics is that you can check your answer, right? And you do have a calculator if you want to do that. But this is not hard to check these two answers. If I plug 0 in, so I'm not going to do this for all of them, but I just wanted to show you how to do it on one of them, okay? So this is, hey, I'm not sure if I did this right. I'm just going to check myself, okay? I'm just checking myself. So I'm going to check each one of these. So I'm going to check x equals 0 first. These are two, I don't know if x equals 0. I'm going to put a little question mark there. So I'm going to plug 0 into the original equation. So I get 3 times 0 squared. And I want to know, is this equal to 15 times 0? Okay, 3 times 0 squared, and I want to know, is this equal to 0? Well, yeah, it is. Look, 0 squared is just 0 times 3, that's 0. Does that equal 0? Yes. So therefore, this solution is an answer, okay? That solution is a solution. Okay, now I'm going to check 5. Okay, I'm going to check 5 too. X equals 5. I'm going to do the same thing, plug that in. So I get 3 times 5 squared, and I want to know, is that equal to 15 times 5? Okay, let's see. Well, order of operations, 5 squared is 25 times 3 3/4, right? 75. And 15 times 5 is 75. This checks out. That means x equals 5 is a solution as well, okay? Now, not all of these are easy to check, right? We're about to get into solutions that have imaginary numbers, that have radicals. They turn out to be a little harder to check. You can, the imaginary you can't check in a regular TI, the 83 or 84, but the radicals you can, okay? So anyway, this is factoring. So step 1, again, step 1, get one side equal to 0. Step 2, factor it completely. And then step 3, set each factor equal to 0 and solve, okay? Great. Okay, so let's do another one of these, but not where we actually have to factor a little bit. And I'm going to tell you, all of us have learned different ways to factor trinomials. I don't mind how you factor your trinomials. I might factor mine a little bit differently, okay? So I'm going to show you 2 different ways to do this. And I'm going to go over, I'll give you kind of what they're called if you want to Google it. There's just a lot of different ways that a lot of different instructors teach how to factor. And it's hard. I can't teach every way, especially in a review session. So let's look at another example. And I'm still solving quadratics by factoring because this is a skill we have to have this semester, okay? So let's look at another one. Let's say we've got x squared minus x equals 12. X squared minus x equals 12. Okay. Same first step, right? One side equal to 0. I'm going to move the 12 over. So I get x squared minus x minus 12 equals 0. And now this is where if you know how to factor this already, you just do it, okay? And I'm going to do it my way, and we'll see if we get the same thing. If you're not sure how to do this one, follow along. So look, the only reason we can do this, what I'm about to do, is because the x squared has a coefficient of 1, okay? If it didn't, it's going to be a little trickier, okay? X squared's got a coefficient of 1. I'm not going to write that there. But because it has a coefficient of 1, I can just make my parentheses, right? And I'm going to put x here. Because if you remember how to FOIL, x times x gives you the x squared. And then all we have to do is think about, well, what two numbers multiply to give me negative 12 and add to give me negative 1, okay? Multiply to give me the constant, but add to give me the coefficient of the middle. Well, 12, if you want to kind of write it on the side, 12 we know is 12 times 1, 6 times 2, 4 times 3. One of them has to be negative, right? And it's got to add up to negative 1. Oh, boom. There it is. It's negative 4 and 3. So minus 4 plus 3. And look, if you want to do a quick check here, multiplies to give me the negative 12, adds to give me the negative 1. Negative 4 plus 3 is negative 1. Okay. So now look, remember, go through the steps again. Step 1, got one side equal to 0. Step 2, we factored this side. Look, this is addition and subtraction, really subtraction, okay? And then it went into multiplication. This means we factored it, okay? So now it's factored into two terms, and we need to set each of those equal to 0. X minus 4 equals 0. X plus 3 equals 0. And then we solve it out, right? Add the 4. We get x equals 4. Subtract the 3. And we get x equals negative 3. Okay? Questions on the Zoom? Now, you're more than welcome to check this. Okay, if you pop 4 in, maybe we can do one real fast. So we pop 4 in. 4 squared, 16, minus 4 is 12. That checks out. Okay, and negative 3 will check out as well. You just sit here. Are you struggling to see it?
Yeah.
You're more than.
Sit in my glasses.
Oh, that's fine. I understand. If you need to sit there, that's fine. You're not gonna. I mean.
I may come sit there.
Yeah, that's fine. Okay. So now think about this. We've solved by factoring. We've solved using the greatest common factor. We've solved by actually factoring the trinomial when x squared is 1. Well, or when x squared, the coefficient's 1. Well, also now we're going to solve when the coefficient's not 1. So let's look at another example of this. Let's say we've got 2x squared. These are kind of harder to make up sometimes. 2x squared, let's say, plus 15x plus 7 equals 0. So hey, I'm going to pause here real fast. You guys on Zoom, you can clearly see this? Like this is okay?
Yes.
Okay, good. If you can't see something, let me know. You're not going to hurt my feelings. Okay, so 2x squared plus 15x plus 7. Now the difference in this one, first off, we've already got step 1 done, right? We got 0 on one side. So the difference for this is that this x squared, this coefficient's 2. So we can't do the nice parentheses thing with x and x and just see what multiplies and adds up. Now, if you already know how to factor this, just factor it. Again, this is when there's so many different ways. There's the box method, the bubble method, the diamond method. I'm going to do a certain method called factoring trinomials by grouping, okay? Factoring trinomials by grouping. So if you want to look this up later, you can. Especially if you're looking at this and you're going, oh my God, I have no idea what to do, okay? Factoring trinomials by grouping, sometimes it's also called the AC method or the bridge method. They're all the same. And I'm going to slow down just for a minute to show you this. Now, what's nice about this, so these are all the same thing. It's just some teacher was like, I'm going to give it my own name so I can feel important, okay? Now, what's nice about this form of factoring is it'll work for the other way too. It'll work for the trinomial that's by itself, that x squared is by itself. It'll work too. Okay, so here's how you do this. I'm going to go step by step, okay? The first thing you need to do, and it's why it's called the AC method, is you multiply the A and the C together. And it's called the bridge method because you can draw a little bridge, okay? So 2 times 7, that gives us 14. Okay, then you're going to ask, we're going to do the same thing we did earlier, actually. It's what two numbers multiply to give me 14 that add to give me 15, okay? So instead of the constant over here, it's the number when you multiply the A and C. So we know 14 times 1, 7 times 2, right? Hey, 14 and 1 multiply to give me 14 and add to give me 15. So I'm going to use 14 and 1. Okay, so here's how we do this. What we actually do is we break that middle term into 2 terms, and it creates a factoring by grouping example. So if you don't know what factoring by grouping is, you're about to learn it. But so what we do is we're going to break this 15x into 14x and 1x. So you break it in half in a way. Well, it's half per se, it's 14 and 1, but it turns into 2x squared plus 15x, plus, oh, not 15, 14x plus 1x plus 7 equals 0. So notice, look, if I add these two together, I get the 15x, right? So we didn't violate any math laws, okay? Not yet, no, I'm joking. Okay, we haven't violated any math laws. And now we're gonna do what's called factor by grouping. And that's why this is really titled Factoring Trinomials by Grouping, okay? Because after this, we're going to do factor by grouping. And if you don't remember how to do factor by grouping, this will be a nice review. Maybe I'll use another color, see if these colors are working. So what I'm going to do first is actually take a parentheses and put parentheses around the first 2 and the last 2, okay? Put parentheses around the first 2 and the last 2. And you're going to ask yourself, okay, what can I factor out of this first set? GCF, this first set of parentheses. Oh, I can factor a 2 out and an x out. They both have 2x. This becomes x plus 7. Okay? And then you want to look at this second set and think, hey, what can I factor out that'll make it match the first set we have now? Now look, for this example, I'll do an example that doesn't do this next time, but for this example, we don't need it to change. This parentheses matches this set of parentheses. So if I don't want anything to change, I'm going to factor out a positive 1. Positive 1 doesn't change anything. Okay. And then we're going to do basic factoring here. Look, this x plus 7 is actually our factor. It's a common factor. It's like if it was z, you would factor it out. Look, if I factored x plus 7 out, I would be left with 2x and positive 1. Okay, I would be left with 2x and positive 1. So that, and I'll do another example of it, but this is factoring trinomials by grouping, the AC method, okay? Factoring trinomials by grouping. What we did is we took this and we made it into 2 sets of factors, okay? And it's okay, if you know another way to do this and you're like, oh, my way is so much faster, that's fine, do your way, I don't care, okay? The goal though is that you know how to factor. You've got to know how to factor these like it's a reflex almost, okay? Because we're gonna, again, this is a review section, right? This is a review section. So now I'm gonna set, just like before, we've got this side factored. We're gonna set each one equal to 0. So I'm gonna subtract the 7. I get x equals -7. I'm going to subtract the 1 and divide the 2. Can you guys see that down there online?
Yes.
Yes.
Okay. Thank you. So x equals -1/2 and x equals -7. Whew. Now look, it just takes more time if the x squared, if there's a coefficient other than 1 in front of the x squared, okay? All right, great. Questions, comments, concerns? No. You might have a lot of concerns right now. Okay, let me steal one, guys, from the book. Yeah. Hold on here. I don't like that one. I don't like that one either. Yeah. Well. Okay, yeah, this is number 84 in your book. If you go to page 161, I'm going to just steal one. It says, solve each equation in exercise 83 through 108 by the method of your choice. But I'll tell you, this one will factor. So 84 here, 3x squared. Where's this? 3x squared minus 4x equals a positive 4. 3x squared minus 4x, it's number 84. Number 84. 3x squared minus 4x equals 4. So I'll work through this one with you. If you want to work ahead right now, that's fine, just to see if you've got it. There's nothing wrong with that. But I'm going to kind of follow up behind you. Okay? First thing we know, we have to get 0 on one side, because I do want you to do this one by factoring, okay? So subtract the 4 over. Three x squared minus 4x minus 4. So again, I've got a number in front of the x squared. So I can't do that easy like, hey, what multiplies to give me -4 and adds to give me -4? I can't do that because there's a number in front. So I'm going to do this factoring the trinomials by grouping. I'm going to multiply the 4 times negative, or 3 times -4. That gives me a -12. And then again, I'm going to ask, what multiplies to give me -12 that adds to give me -4? Well, let's just do the rundown. 12 times 1, 6 times 2, 4 times 3. Ugh. It's going to be -6 and 2, right? That multiplies to give me the -12, adds to give me the -4. Now, again, remember, guys, I've got to break this apart, right? And now I'm going to do this example a little different. I'm going to put the negative second to show you what to do if you have to deal with a negative. So if we have 3x squared, now I'm going to put the positive 2x first. And then minus 6x minus 4. Okay, so when you do factor by grouping, okay, so notice, look, 2x -6. And make sure they're x's, because when you multiply or add them together, they've got to add up to -4. But notice when you do this, it makes a minus sign here. It's not a big deal. So now we're going to do the factor by grouping part. And when you do that, you actually have to put a plus sign. And look, plus signs don't change anything. It's fine. So parentheses plus parentheses. Okay? So if you have to rewrite that, that's fine. But look, 3x squared plus 2x, put that in parentheses, the first two, plus minus 6x minus 4, put that in the other set of parentheses, if you want to do this type. It's my first time to honestly lecture in a normal way since March. It's crazy. I like it. I miss this so much. Okay, so let's factor the first set out. Look, we can only factor an x out, right? 3x plus 2. And in the second set, I want it to match. So what do you think I need to factor out here to match this first set? Alon, what do you guys think? What do I need to factor out of this set to match this set?
3x plus 2.
What do I,
Oh, factor out.
yeah, what do I need to factor out here?
2.
It would be a 2, but what about the 2? Online? Nothing? Ooh, okay. Now, if you already know how to factor this, that's fine. If you're watching this for the first time, you're not getting it, you need to go back and do some more examples of this, okay?
Yeah.
It's -2, guys. It's -2. So then you wind up with, look, if I factor out a -2 here, it makes this first one positive, and it makes the second one positive. And that's what I needed. Okay, that's what I needed. So I've got both of these to match. And remember, if they match, I can factor them out because it's the common factor. So I get 3x plus 2. And I'm left with whatever's in front, x minus 2. Okay, now if you got that, if you're like, no, I did the guess check way, or I did the whatever bridge way, whatever way you learned it, as long as you get to here, that's what matters, okay?
I got something different, but I think it's because I did 3x squared minus 6x plus 2x instead of the other way around.
Oh, you would have got the same thing. You would, no, you would need to factor out a 1, right? From, no. Okay, yeah, no, hold on, let me think.
I don't know what I did.
No, you're fine. You need to factor out a 2 from that second set. Look down at it.
Yeah, I factored out a 3x.
From the first set, right?
Yes. Oh, okay.
No, that's, and this is why we're doing this. Okay, this is why we're doing this. So hold on, I'll press pause on that.
Okay.
If you said, hey, I want to put the -6x first. So look, I'm going to go over here, guys. Got 3x squared minus 4x minus 4. And I want to put the -6x first. That was plus 2x, right?
Yes.
So then you put parentheses around the first two and the last two, right?
Yes.
The first one, you could factor a 3x out. You're left with,
3 minus, or x minus 2.
yep. And then what do you factor out the second set?
I factored out a 2.
Perfect, okay.
2x minus 2.
That would be x minus 2, right?
Yes.
And then you factor, look, this is the common factor. So we factor it out, and we're left with 3x plus 2. It's the same thing.
Oh, I did get that answer.
Yeah.
I just factored it out all the way to a -2/3.
Yeah. Oh, yeah, you solved it, right?
Yeah.
Okay, you
that's
solved it. Yeah.
what I guessed.
Yeah, look, it doesn't matter the order that you put these in. Notice this is 2x minus 6x, and this is -6x plus 2x. Doesn't matter the order. In the end, you'll wind up with the same set of factors, right? And order doesn't matter with these two factors, right? Because it's, what's that property that says multiplication when you order it? The order doesn't matter. What's the, ooh, some good brownie points right here. Math brownie points. What's the property that says order doesn't matter with multiplication? It's also with addition too, right?
Order of operations?
No, that's like PIMDAS. That's like which one to do first.
Commutative?
Say it again.
Commutative?
Commutative. You're right. It can commute around, right? So like 5 times 2 is the same as 2 times 5. That's just brownie points for at this point, okay? But now, okay, let's go back to here. You were right. Whoever said that, congrats on the brownie points. 3x plus 2 equals 0. X minus 2 equals 0. This is the bummer part. I don't know who's talking on it, you know?
That was Kaylee.
Kaylee, congratulations, Kaylee. So I'm going to solve for x here. So subtract the 2, divide the 3. So you wind up with -2/3, right? Subtract the 2, divide the 3. And then add the 2 over here and you wind up with x equals 2. Yeah, the crowd goes. So I got to write down, this class gets out at what, 10:40? Yeah. I'll write that down so don't forget. Okay? So solving quadratic, and guys, if you're like, oh my God, Mr. Shirley, I don't know what I'm doing, email me and I'm going to send you some stuff to kind of catch you up a little bit. So that's why I'm going over this section, to make sure we are where we need to be. Okay? So I need you to know how to factor. And really, I would say the solving part isn't as important for factoring, because we're going to get to points where we have to factor to simplify things down. So it's actually the factoring part that matters more to me. Solving actually turns out to be, we can use a quadratic equation on all these and solve them, okay? And we'll get to that here in a minute just to review it, but I'm not as worried about the solving. It's knowing how to factor, because you've got to know how to factor, so therefore we can simplify later on. Okay, we can simplify this thing later on. Okay, great. Okay, so that's my spiel about solving by factoring. The next thing we're going to talk about, excuse me, actually let's do a special quadratic that pops up a lot. So I lied. Give me one more minute here. It's the difference of squares. And this happens all the time. Your book, Dr. Blitzer, who wrote this, he likes throwing in this difference of squares factoring. And there's nothing wrong with it, but I just want to hit it here so we've seen it. A difference of squares looks like this. If we have any two terms, that can be squared, right? And there's a subtraction sign. It's called difference. We can factor this one really, really easy. It's a minus b times a plus b. And these two factors are called conjugates, okay? They've got a name and they're important. They'll pop up again, but they're called conjugates. So let's look at a basic example. If I've got x squared, actually, I'm gonna make it a little different. I've got 9x squared minus 25 equals 0. 9x squared minus 25 equals 0. Okay, this I can align with my difference of squares, because the first term I can write as 3x squared, right? Because 9x squared, 3 squared is 9, x squared, of course, is x squared. 25 is 5 squared, right? So that's my A and that's my B. There's my A and there's my B, okay? So if that's my A and that's my B, I can pop it into conjugates in one step. I don't have to do all of this stuff, okay? It's a shortcut really, if it works. I mean, it's got to be in this really special form for it to work. But it's 3x minus 5, 3x plus 5, okay? 3x minus 5, 3x plus 5. So this is called difference of squares. If you want to look it up, difference of squares. And I'm not sure it'll pop up a lot in today's homework, but it is something that just kind of happens. He uses it a lot. So now look, I'm going to set each one of these equal to 0. Man, there's some water. And what's going to happen is if you have difference of squares for factoring, the answers are going to be really the same number, just opposite signs. So we add the 5, divide the 3. We wind up with 5/3. Subtract the 5, divide the 3. We wind up with negative 5/3. Okay? So same they're opposite numbers, right? 5/3 and negative 5/3. And that's what happens if you have this difference of squares, which is kind of neat. And again, I don't know if it'll pop up per se in the homework, but it is kind of neat when it does happen. And it's quicker. You don't have to do all this stuff. Okay, so let's get to the next part. Now, the next part's the square root property, which is really nice to use if we can use it. And we can typically use this whenever there's no x value. So when it looks like this, let me give you an example. If we had 2x squared plus let's say 100 equals 0. Now this is called, I'm gonna solve this using the square root property, or the square root method. Sometimes it's called method. I guess, yeah, it would be the square root method really for how we're gonna do this. And notice there's no x up there, right? We've got the x squared and we have the constant. And when we have an x squared and we have a constant, which kind of like this one actually, this would be easy to use as well. But if we've got x squared and a constant, we can use a square root property, and it's a lot easier than the square root or than the quadratic formula, which we'll get to here in a minute. But to use this square root property, it's different than factoring. That it's not that you have to solve for 0 to begin with. You have to get whatever is squared by itself, okay? You got to get whatever squared by itself. So our goal first, step 1, is to get that thing isolated, okay? So I'm going to subtract the 100. I get 2x squared equals negative 100, right? And then I'm going to divide both sides by 2. I get x squared equals negative 50. Okay, so now we did step 1. That's step 1. If you like writing steps down, step 1 is to get this thing isolated. Now, this thing might wind up being a little binomial. We'll do that here in a minute. But for now, this thing we've got to get isolated. And once we do that, we can just take the square root of both sides. But you have to remember a property that says if you take the square root of both sides, you have to attach a plus or minus, okay? So when you do this, you have to attach a plus or minus. So the next step is I'm going to take the square root of both sides. But if I do that, I have to put a plus or minus out here. I have to put a plus or minus. Okay. Now we've got to remember how to simplify radicals. So, the square root of x squared is just x, right? And I'm hoping you guys remember how to simplify radicals. If not, I'll do a quick little example of it. Not a big deal. First off, this square root's negative, right? So if we have a negative square root, it's not real, it's imaginary, right? So the first thing I'm going to do is take out the I. Because it's negative, I'm going to write this as plus or minus I square root of 50. And then there's really 2 ways to simplify radicals. There's using the perfect square factors, or there's using a factor tree. And I don't know how you learned it, but typically students learn this using perfect squares, right? What is a factor of 50 that is a perfect square? That's 25, right? You guys hear that? 25. So 50. So therefore we can write this as the square root of 25 times the square root of 2, right? 25 times 2 is just 50. And we know the square root of 25, square root of 25 is just 5, right? Now, look, we write the I second. So when I take the square root of 25, it is just 5. So it turns out to be plus or minus 5i square root of 2. Now, look, those are my 2 solutions. I'm not sure who said or who asked me earlier about how to write the answer, but I'll tell you in the book, it's going to write your answers in this set notation. It's a bracket notation. I'm glad you said that actually. So I don't think it actually answers this as, it's not going to answer it as plus or minus 5i squared root of 2. It's going to write it next to each other. Same for this one. I should be kind of doing this so you know you can kind of match it up. But it uses these squiggly brackets, okay? Because that means it's a set. So we have a set of answers. We've got 5i square root of 2. And we have negative 5i square root of 2. So if you look at the back of the book, that's what the the two answers are gonna look like, okay? Now, no, this is the same exact thing. It's just written two different ways, okay? It's just written two different ways, and on the test, I believe I write it like this because I'm consistent with the book. The test generator I use is actually published, or it's the same publisher as the book, so it should be the same. It should look like this, okay? If it just doesn't make sense, let me know. We'll go in there and check it out, okay? Question. So that's the square root property. And notice the square root property wasn't hard. We dealt with more about solving radicals. I think that's typically harder than actually using this property, okay? Let me steal one from the book to do. Let's see here. Ooh. Okay, I want you to try this one. This is number 18. Try it. 3x squared. 3x squared minus 1 equals 47. 47. 3x squared minus 1 equals 47. So try this one. So I want you to do the square root method on it. But try this. I'm going to get some water real fast. So try this one. I'll be right back.
I'm a little confused.
That's okay. Let's work this through then. It's okay. Remember, the goal for this one is to get the x squared by itself first, right?
The
So-
one threw me off.
Wait, what'd you say?
The one in the middle threw me off.
Yeah, you got to move that one over, right? So you add the one to the other side, you get the 48, right? We good there? Okay. Divide the 3. What's 48 divided by 3?
16.
Oh, this is nice, because 16 has a perfect square, right? Or a square root. So now we take the square root of both sides. But when we do that, we do not forget to attach the plus or minus. Right? We take the square root of both sides. This one's a lot easier to simplify than the negative 50, right? I mean, we got a real number. It has a nice square root. So we wind up with our two answers, plus or minus 4. Now, remember, at the very beginning, I mentioned, hey, it's not a coincidence that we have two solutions and our degree was 2. All quadratics, every single quadratic you're going to work on this in this section, it's going to have a degree of 2. It's going to have 2 answers. Now, it might have 2 repeated answers. We haven't seen one of those yet, but it will have 2 answers, okay? And again, look, if I was grading this on paper, this was a normal class, pre-pandemic, okay, I would take this as your solutions. But realize if it's a multiple choice question, or if you're checking your answer in the back of the book, right, it's probably going to look like this, -4 and +4.
And there's no I because the square root of 16 wasn't negative, right?
Bingo.
Okay.
Yep. You're exactly right. Look, we had a -50. I wanted to do two kind of totally different radicals. We had a -50, so that meant I'd take the I out first, right? So, and that's kind of what I do. And again, if you're like, man, I need just a little catch up on simplifying radicals, if you just Google, got on YouTube, how to simplify radicals, or if you want to email me, I've got some more videos on that one. Just let me know. Okay, good questions. Good stuff. That's why I'm going over it. Okay, let's do one that doesn't quite look like this, but we're still going to use the square root property. Okay, we're still going to use the square root property. Wish I had like a screen here so I could see their faces.
Yeah.
It's a bummer. I'm gonna try to figure out a way to do that. Okay, or at least see the names. Okay, because it feels impersonal. Like impersonable. Okay, let's look at another one. This is number 24. Okay, I'm just going to kind of go down the line. 24 here. We've got, steal it, 3 parentheses, x plus 4 squared equals 21. 3 parentheses, x plus 4 squared equals 21. Now, look, this one does not look the same as this one, right? There's parentheses going on, but listen, this whole thing is being squared. So that's what we're going to treat as our squared term, okay? We're not going to FOIL it out. Oh, good. Do not tell me it's x squared plus 16. Look, this does not distribute in because there's the plus sign. If you just don't want to do this method, you'll have to remember, oh gosh. X plus 4 squared, you have to multiply out like this. Okay, you have to multiply out and then do the foiling and all that fun stuff, okay? Don't tell me it's x squared plus 16, but we don't have to do any of that because we're going to use the square root property. And to do that, remember, we've got to get whatever is squared by itself. Well, that whole thing right there is being squared. So I've got to divide this 3 off. Both sides, it's an equal sign, right? So we wind up with x plus 4 squared equals 7. Okay, x plus 4 squared equals 7. And then now we're going to do the same exact thing we've done before. And it looks different because it's a binomial being squared, but it's the same. Okay, so I'm going to take this square root of both sides. Don't forget the plus or minus. It'll be the one thing you forget. And now what's nice is because this entire binomial was being squared, when we take the square root of the entire thing, it goes away. So you wind up with just x plus 4. They cancel each other out, right? Kryptonite and Superman. They just cancel each other out. Whew. 5 years, somebody's going to watch this video and go, oh, I know exactly when this was made because of the mass. So plus or minus the square root of 7. Now, look, now we can't simplify 7, right? 7's a prime number. It doesn't simplify out, right? There's nothing divisible into it that has a nice perfect square. So it's just going to stay put. We do have to move the 4 over. Now, when we do this, I want you to be careful. It's going to be -4 plus or minus the square root of 7, right? -4 plus or minus the square root of 7. We put the constant on the front of these and then the plus or minus. Now, again, your book is going to say parentheses -4 plus the square root of 7 and -4 minus the square root of 7. Okay? The squiggle brackets are kind of hard if you're writing them. Don't know what I'm talking about. Then -4 plus the square root of 7 and -4 minus the square root of 7. Okay? Great. I'm going to pause right here for a minute, and I'm going to ask you guys, do you have any questions? We've gone over how to solve by factoring and how to solve by the square root method. We're going to go over one of the ways of solving, which typically is the one students remember the most, but it's the hardest to simplify.
Is there a name for how you write the answer?
Set notation. Yeah.
Thank
Yeah, this
you.
is, yeah, no problem. Took me a minute. This is called set notation. And it's when you have more than one solution. And it's not, like before, and I'm not sure if you were the one that asked me about this, about making it like coordinates. And, if it was coordinates, it would be parentheses, and you have so many parentheses, maybe so many sets of coordinates. But for this, these are just the solutions. So, yeah, set notation is how you would define that. Okay. If you've got no more answers, let's go over the one method that students typically remember. There's some jingle that you remember because some high school or junior high teacher like pounded into your head and you had to memorize it over and over again. But the quadratic formula. Quadratic, it's not formula. Wait, no, it's formula. Yeah. Quadratic equation, something else. Quadratic formula. So if we're going to use the quadratic formula, and I'm hoping you've seen this before, this is not the first time you've seen it, but if we're going to use it, it has to be in the form ax squared plus bx plus c equals 0. We have to have it in this form. Don't mess up the easy stuff, okay? Don't mess up the easy stuff with this one. It's got to be in this form. I mean, the rules state like a, b, and c have to be real numbers. A can't be 0 because then you're just a linear equation. It's easy to solve. Don't worry about that. We've got to get this in this form, and then we can use the formula, right? Which, do you guys remember? It's like Pop Goes the Weasel, right? Do you guys remember this? Oh, yeah. X equals negative b, always negative b, plus or minus the square root. Square the b. Be careful when you square the b. If you want to write it like this, you're gonna save yourself some headache. B squared, whatever b is, squared. That way, if it's negative, you know to square the negative. B squared minus 4ac all over 2a, right? Okay. What's nice about this is we get our answer from an equation. What's not nice about this is we have to remember an equation, okay? There's pros and cons to it. The hardest part of the quadratic formula, hands down, is simplifying it. So before we even, we got a little bit of time. I'm gonna stick 3 minutes on how to simplify. So I'm gonna pause this and we're just gonna talk about simplifying fractions, okay? And what I'm gonna do is I'm gonna use, like if we pop the equation, things in the equation, what it's gonna look like when we get out of it, okay? So let's say we put something in this equation. So this is just simplifying fractions. It's a separate example. Put something in this equation and we wind up with 2 plus or minus 4 square root of 2 all over 6. So we pop something in this equation and it comes back to this and we need to simplify it, okay? 2 plus or minus 4 square root of 2 all over 6. Now, the rule is we've got 3 separate terms in this fraction. Notice this. I'll use another color. We've got the 2. We've got the 4 square root of 2. And we have the 6. Those are 3 separate terms. So if we can simplify this, a number has to be divisible into all 3 of those terms, okay? And look, with this radical, it's whatever's in front of the radical. That's not really a 2 there. It's a square root of 2. It's a weird number, okay? So if we look at this, 2, 4, and 6, well, what's divisible into all 3 of those? 2, yeah, not everybody wants, right? 2 is divisible into all 3. So what we can do is divide 2 into all 3 parts. 2 divided by 2 is 1, right? Don't tell me it's 0 and it goes away. It doesn't go away. It's just 1. 4 divided by 2 is 2. Okay? And then 6 divided by 2 is 3. Okay? 6 divided by 2 is 3. Okay? That's one thing that can happen when we start working on these. And if you think of it as 3 parts, something's got to divide into all 3 parts, it'll really help you get to the final answer correctly, okay? So let's do another one. Let's say we've got 4 plus or minus the square root of 20 all over 10. 4 plus or minus the square root of 20 all over 10. Now, the way this is written, we can't divide anything to all three, right? You've got a 4, a square root of 20, and a 10. Square root of 20, we can't divide 20 by anything right here. It's a square root of 20. But what we have to do is simplify the 20. So we're going to simplify this 20 first. I'll do it over here on the side. 20 can be written. Now, what's a factor of 20 that has a nice square root?
Four.
4. Yeah, it's 4. So we'd have the square root of 4 times the square root of 5, right? Remember, numbers, oh my God, wrong with her. Remember, numbers with nice square roots, 4, 9, 16, 25, so on and so on. Okay, so this square root of 20 turns out to be 2 square root of 5, right? So I'm going to put that into my fraction now. 4 plus or minus 2 square root of 5 all over 10. And now let's look at this, all three parts. Okay, we got a 4, a 2, and a 10.
I have a question.
I'm listening.
So regardless what it is, we still have to do it to where there's 3 parts.
Can you expand that question a little more?
So like on the other one, it was already put in 3 parts, and this one we had to put it in 3 parts. So is all of these going to have to be with 3 parts, or?
Well, the quadratic formula is going to crap out 3 parts. Is that what you mean? So it automatically is going to put out 3 parts. So therefore, that's why I'm kind of going it this way, where you have to find something that divides into all 3 of these parts.
Okay.
Does that help? Does that answer it?
Yeah.
Okay. So
Okay, I have a question too.
Yeah.
So when you did the square root of 4 times the square root of 5,
Yep.
the 4 and the 5, that was like intentional, like that has to equal.
Yeah. Whatever this is has to multiply together to give you 20. Yeah.
And so then you just did the square root, which was 2, and that's how, okay,
Bingo. And you always put the nice perfect square root out front,
okay.
because then it parks it where it needs to be out here, right?
That
Okay.
makes sense.
Yeah. So now let's divide by 2, and we wind up with 2 plus or minus the square root of 5 over 10. Okay. Let me try to think of other things that might happen here. Actually, let's kind of dig into this now, and then just so, because we're not too far from being done with class today. So let's at least get a few examples in that maybe look a little different than this, but you'll see where I'm.
Can I ask you why you still have the 10? Wouldn't the 2 go into the 10?
Oh, no, that's a great question. So now remember, we have 3 parts, right? And there's nothing that divides into all 3 of those parts. Do you see that?
Yes.
So I'm glad you asked. Is that Janette?
Yes.
Yeah, I'm glad you asked that, because look, it's still 3 parts, and so you have to think, the 2 and the 10, they're gonna fake you out. Okay, the 2 and 10, you're gonna go, oh, that's 1/5. I've been doing this for a long time, but it's 3 parts, so that's why. So it's 2, 10, and really it's a 1 out here, right? You really look at that 1, that coefficient of 1, and there's nothing that divides into all 3 of those. I'm glad you asked me that.
How would it not already be a 5 from the beginning?
What'd you say?
How would it not already be a 5 from the beginning equation, from the 4, the 2, and the 10?
Oh, I see what she's saying.
Oh, it would be a 5. I was making sure you guys were paying attention.
That's what I meant.
Oh, I'm sorry, Jeanette. You were correct. Yeah. That would be a 10. I apologize. I messed up there. You all get brownie points for paying attention, right? Okay. Thank you guys for fixing me there. Okay, so let's do at least an example or 2 before class ends on this quadratic formula. So I'm going to steal one from the book. Let me find that.
I have a question before you get started on that.
I'm listening.
How would the book have us write it? Would it be like that on the 2 plus or minus the square root of 5/5, or is it a different way?
You know, it looks like it writes it both ways. Let's do this one and I'll show you. It really does look like it's kind of doing it both ways, which I'm not a fan of. I wish it was more consistent. And I'll show you what you're asking me there here on this next one, okay? Let's look, I know this isn't, yeah, let's look at 74. 74 says x squared minus 2x plus 17 equals 0. Okay, x squared minus 2x plus 17 equals 0. Because I have the answer written right here, so I can show you how when we get to it how it wants it answered. So now I've got to pull my a, b, and c out. A equals 1, b equals -2, and c equals 17. And then we're going to just pop it into that formula that I just erased, right? But remember, it's net x equals negative b, so it's going to be -2, plus or minus the square root. And this one you got to be careful. We got to square the b, but we've got to square all of b, all of -2. Okay, b squared minus 4 times, was it 4ac?
Yes.
All over 2a. Okay. Now, when I solve these out, you guys can keep writing if you need to write. When I solve these out, I find the discriminant first. The discriminant's what's underneath the radical. And I kind of do this on the side, just so I don't have to rewrite everything 10 times. Now, I need your help here. I know this is a 4. 4 times 17, that's 68.
Yes.
Okay. So 4 minus 68 is -64, right? So I get -64 under the radical. So I like doing that on the side so I don't just write it, 6 times. So it winds up being x equals +2 plus or minus the square root of -64 over 2. X equals 2. +2, because remember it's negative, right? Plus or minus the square root of -64 over 2. Now, look, square root of -64 is not bad. I know the square root of 64, which is just what? 8, right? Now, it's negative, so what does that mean?
You get 9.
And you get 9, yeah. We get 8 eyes. Okay, so we get 2 plus or minus 8i all over 2. Questions so far? And notice how this how like I did these examples over here, it kind of pops out into this form, okay? It pops out into this form. And then we have to simplify, and this is where students typically struggle. And look, I can't add the 2 and the 8i. That's a real number and an imaginary number that you can't add or subtract. And you can multiply them or divide them, but you cannot add or subtract them. So then I'm going to do the same thing I did before. I've got to look at all 3 parts. Okay, the 2, the 8i, and the 2. Well, what's divisible? Again, I didn't mean to choose the same number every single time. But what's divisible into all 3 parts? 2, right? So you wind up with a 1 plus or minus 4i all over 1. And I know what you're thinking. Hey, Mr. Shirley, you don't have to put divided by 1. And you're right? Anything divided by 1 is itself. So you don't have to write the -1. So the answer, and I'm not sure who said that earlier, I don't have the voices down yet, but the way the book answered it actually was like this. They wrote it like this. 1 plus or minus 4i. So I guess he was just kind of picking and choosing when he wants to use the plus or minus. But that's the way the book answered. Now, I do want you to understand if for some reason on the test, this was written as 1 plus 4i and 1 minus 4i, it's the same answer, okay? It's just 2 different ways to write the same exact answer, okay? Great. Great. Actually, this is good stuff.
Do you have a preference on how you want us to write it? Like for
No,
homework?
I don't have a preference. I know that for this class, you're taking those tests on Blackboard, so it wouldn't matter what my preference was. I just need you to understand that if you see either one of these, they mean the same. Yeah. I probably, on a test, I'd probably prefer you to do the plus or minus just because it's, I don't know, it just makes sense to me. But also this way lets you know that it is two distinctly different answers. Okay, so for homework, guys, I've got you. It's almost into class. I didn't get to 1.7. We'll talk about what I want to cover in 1.7 at the beginning of class on Tuesday. Man. So for homework, now this starts on page 160. 160, remember this is section 1.5. And I want you to do 1 through 33. These are all going to be odd, guys. 1 through 33, and then I want you to do it a little skip action. 65 through 73. And then lastly, 83 through 103. Make sure. Oh, yep. And also, and I know I haven't talked about this, but this is a concept we should be able to do. If not, I'll answer it at the beginning of class on Tuesday. I don't mind going over it. But I also want you to do 109, 111, and 113. So I guess I'll say 109 through 113. It's the x-intercept aspect. And I know we didn't hit it in here. It's okay. Just attempt it and see what you get. So these are all odd, guys. All odd. Give me 1 second. Pause the video.